Hello learners, welcome to this tutorial on Arduino Mega Board programming and simulation. So in this tutorial also I am going to discuss about a switch activated LED program. So in the earlier tutorial I have showed one way of doing this objective. So in this tutorial I am going to do it in another manner. So here the Proteus part will be similar, only the embedded C programming is going to be different from the earlier version which I have discussed. So we are going to use Arduino IDE for writing our embedded C program and converting our embedded C program into a hexadecimal file. Same way we are going to use a Proteus 8 simulator to check whether our program logic is working properly or not. So first let us define the hardware part. So we are going to use a Arduino Mega board which contains Atmega 2560 microcontroller, and I am going to interface a push button to pin number 11 of your Arduino Mega board, and I am going to interface a LED which has two terminals, anode and cathode, and anode terminal I am going to connect to the pin number 7 of your Arduino Mega board. So the working logic of our program will be, when we try to push the switch, the status of the switch will be displayed in the LED. So let us dive into our Proteus part. First I am going to create a new project. Go to a location where you are going to put your new project. Select the folder and define the project name. So I will put it as switch activated LED. So we are doing two things here. One is selecting the location for storing our project and try to define our project. And the project name will have an extension of .pdsprj. So I am doing this, press next. First thing we have to select is a template, the location where we are going to build our circuit. So I am going to use a default schematic of some standard size. Press next. We are not going to do any PCB layout, so I am not going to create any PCB layout. So I am going to leave that option as it is. Next, and I am not going to use any firmware. Press next. So here you can see only the schematic is selected. Press finish. A schematic has been loaded. So now we need to build the circuit. For building the circuit, we require the components. For selecting the components, I go to the left side, tick device, a new window will open. In the keywords, I need to type the component name. So first component name which I am going to type is Arduino, and I will select the Arduino Mega 2560 board. So double click on this, it will get added to the list of your equipments. Next thing which I require is a push button. So I type push button. I get a push button here. Double click on this, it will get added to the list. Same way I am going to select an LED. Here I am going to select an animated version of an LED. I am going to select a green color LED. Double click on this, it will get added to the list. Next thing I want is a resistor. So I will try to take a resistor. Double click on that, it will get added to the list. So these are the components which I require for this project. Once I selected all the components, I press OK to come out of this window. So now we have selected the components, we need to create our circuit. So for creating the circuit, first component which I am going to select is Arduino Mega 2560. So when I click on that, the board will appear in this window, and I go to the schematic, wherever you require, you press, so that you will get the Arduino Mega board. So I am going to put the board at this location, and as per our hardware connection, we want to connect the push button to pin number 11 and LED to pin number 7. So I am going to select a push button, put it in this schematic window, and connect one end of the push button to pin number 11. Another end I need to connect it to a supply. So I go to terminals mode, select power, put it into the schematic and connect the power to the other end of the push button. So here by doing this, the pin 11 will be at high impedance state by default. Whenever I press it, it will go to logic high. So the pin will change from high impedance to logic high. So this is an undesirable feature. So in order to make the pin to go from logic low to high, I am going to put a resistor in this location. So for putting a resistor, again I am go to the components mode, select a resistor. Now I want the resistor to be vertical, so I rotate the resistor and then I place it onto the schematic. And one end of the resistor I am going to put it into the push button. Other end I need to connect a ground. For again connecting a ground, I go to the terminals mode, select ground, put it into your schematic. Then connect the ground to the resistor. So now the input side is over. So now we need to connect an LED. So for connecting an LED, again I go to the components mode, select an LED, place it into the schematic. So now I want to connect the anode part of your LED to pin number 7. And the cathode, I want it to connect it to ground. For connecting it to ground, again I go to terminals mode, select ground, put it into your schematic. Then connect the ground to the cathode of your LED. So now we are done with our circuit. So we have connected a push button, we have also connected our LED. So I can save this project. After saving this project, we need to write our embedded C program. For writing an embedded C program, we need to go to Arduino IDE environment. So in Arduino IDE environment, so we are defining two variables, push button and LED. So push button is initialized with the value of 11, which is equivalent to the pin value 11, where we are going to connect our push button. Same way LED is connected to pin number 7, so LED variable is initialized with 7. So in the void setup, we put the configuration part of our microcontroller. So we need to do a configuration because one of the GPIO pin, I am going to use it as an input pin. Another GPIO pin, I am going to use it as an output pin. So we use the function called as pin mode. So pin mode, I define the variable push button, which is nothing but 11, which is equivalent to pin number 11. And the pin number 11 is set as an input pin. Same way, pin mode, pin number 7 is initialized as output pin. So we have configured our microcontroller. So now we need to define the logic. So the logic will be defined in the loop function. This function will be executed infinite number of times. So in this function, first thing what we are going to do is we are going to read the status of the push button. How to read it? Using the digital read function. So digital read of push button. So if the switch is pressed, I will get 1 or it will be 0. So that status will be available in the button state. So now I am going to check the state, whether it is 1 or 0. So that is done using the if statement. So if button statement equal to high, which means the switch is pressed. If the switch is pressed, I am going to make the LED to be on using this function digital write LED comma high. This value will be retained for 100 milliseconds. If the switch is not pressed, then it will go to the else part of your if statement. In that else part, we are going to make the LED to go to off state by putting digital write LED comma low, and this value will be retained for 100 milliseconds. So once the if statement gets completed, again it will go and read the status of the push button, again check the logic, depending upon whether it is high or low, a particular section of the if statement will get executed. So this completes our code. So now our program is ready. We need to convert this program into a hexadecimal file so that it can be imported into the Proteus environment. So first let me save this code. So I'm going to save this program as LED push button 2 dot C. This you have to remember. So it should be saved with an extension of dot C. Save. Once I have saved the program, I can convert this program into a hexadecimal file. Go to Sketch, export compiled binary. When I do that, it will get converted into a binary file. So that we can check using our location. So in Arduino LED push button 2, you can see a X file has been created. So I can open this file to see the opcode values. I open this file with the help of a notepad. You can see this is the opcode file which we are going to put into the program memory of your microcontroller in Arduino Megaboard. So now we are ready with our hexadecimal file. Now we can import this file into this hardware circuit in the Proteus environment. So right click on this, edit properties, in program file, select the file. So I select the hexadecimal file, open, okay. So now we have imported the hexadecimal file into your Arduino Megaboard. So now we have to check whether the programming is working properly or not. So in order to do that, I go on the left side bottom corner, run the simulation. When I run it, right now the push button is in off state, so the LED is in off state. So when I press it, what will happen? The pin number 11 will go to high. So since it is high, LED will turn to on. So when I press this, you can see the LED glows. It will glow until I press the switch. If I release the switch, you can see the LED turns to off state. So this is another way in which we can write a switch controlled LED. So for an embedded system design, we can write the programs in multiple ways to achieve a common task. So in order to stop this simulation, I press stop button here. In the next tutorial, I will be discussing about LCD programming. Thanks for watching. Please subscribe for more technical learning. Thank you.